Hello and welcome to this special AeroTime interview on Earth Day. My name is Martin Popplewell and I'm delighted to be here to interview our guest today, Amy Ruddock, the Vice President for Europe for Carbon Engineering. After studying natural sciences and then a PhD in chemical physics at Cambridge University, Amy spent almost 10 years as a consultant at the Boston Consulting Group. She then became the Vice President of Corporate Development and Sustainability at Virgin Atlantic, a role that covered sustainability, corporate strategy, government affairs, and Heathrow expansion. In December 2020, Amy joined Carbon Engineering, a specialist in direct air capture, where her regional accountabilities include strategy, government affairs, and business development. Amy, thank you for joining us here at AeroTime on Earth Day. I think my first question is direct air capture. What is it?
So I think a really good analogy we could think about is a bathtub. If you saw that a bathtub was overflowing with water, the first thing you might do is go and turn the tap off. But that tap is a little bit sticky and you're still going to get drip, 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 drip. The other thing I think most people would do is go and pull the plug out. Now the analogy here is that water in the bath is like carbon dioxide in the atmosphere. We're getting dangerously close to the top. We need to turn that tap off. But there are some very hard to decarbonize industries where there will be that drip, drip, drip. And one of those industries might be aviation, in particular, long haul aviation. So we need to be pulling that plug as well. Direct air capture is one of the ways to pull that plug and permanently remove carbon dioxide from the atmosphere.
And so when it says direct, I have this impression of there being something stuck on the aeroplane which is taking the carbon as it pumps it out. Is it like that? Because I'm aware of other concepts which are about how do we actually just take out carbon dioxide that's already in the atmosphere out, but direct carbon capture sounds like it's actually taking it out as the plane pumps it out.
Very good analogy, actually. I would say it's in its action, it's very like having a tailpipe extractor. But that tailpipe extractor is actually on the ground. Mounting direct air capture on the back of a plane probably just isn't going to work physically, the ability to take off. But it's doing exactly the same action, but on the ground.
So it's not selectively taking carbon which has been pumped out by planes. It's taking carbon from wherever it's come from out of the atmosphere and then essentially putting it somewhere where it doesn't warm up the atmosphere and cause the problems that carbon dioxide does. Is that right?
Exactly. So wherever carbon is emitted, it very quickly disperses across the atmosphere. So actually direct air capture allows you to remove that carbon from anywhere, and the anywhere that you pick is the most favorable locations to run a plant.
And so there are going to be physical bits of infrastructure, are there, on the ground, which are going to basically suck in air which has got more carbon dioxide than we would like in it, take it out, the carbon dioxide, and then pump out that air with less carbon dioxide.
Yeah, exactly. So we've just hit 420 parts per million of carbon dioxide. There's a lot of debate over what the safe levels are, but let's say a lot centering on around 350 parts per million. That's a lot of carbon dioxide to remove. So we have a technological solution. We extract the carbon dioxide from the air, and then through a chemical process, we produce a concentrated stream of carbon dioxide. That's our product. You can then either sequester that underground into geological formations, or you can use that product to make things like drop-in compatible transportation fuels. The former gives you a negative emission, so almost the equation 1 + -1 = 0. And the latter is more a circular economy. So you're producing transportation fuels that result in CO2 circling around the atmosphere rather than putting more fossil fuel into the atmosphere.
This sounds like a get out of jail free card, because if we can take out that carbon dioxide that we don't want there and reduce it down to the levels that the planet can cope with, does that not mean that then we can actually just not worry about flying anymore in terms of the impact that it has in terms of releasing carbon into the atmosphere?
the most important thing is you need to reduce as far as possible first. There are many things that airlines can do to reduce further, including efficiency measures, including what air traffic control does. And then on top of that, the next generation of fleets that will come, electric hydrogen, certainly for short-haul aviation, they are going to be real solutions available. So reducing as far as possible is very important. And in many cases, reducing is a cheaper pathway. So there's not the economic case to go to direct air capture. But when you think about things like long-haul aviation, where there isn't a proven technology to fly without carbon fuels at the moment, you are going to need using them as long as we see a business case for aviation. So that is where things like direct air capture come in, that you produce, that you're able to do that at a capped and known cost in a net zero aligned way.
So I'm thinking about these sort of tunnels on, not tunnels, these chimneys. I'm thinking about these chimneys on the ground, which are sucking in air which has too much carbon dioxide in it and processing it. You know, when I'm thinking about that, I'm thinking, well, surely that requires energy to do it. Would there be certain countries like Iceland which, you know, have sort of almost limitless amounts of electricity because of all the geothermal activity underneath, that might be a good place to stick these chimneys to suck in the air, because a cheap, in fact, basically inexpensive free energy, which doesn't have any kind of impact renewable energy, is almost limitless there. Would that be a good place to site them?
It is. So there's two things that we think about when we think about where to place plants. The first is, where is the sequestration available? So as I mentioned, when we have CO2, we can either sequester it underground or we can use it in products. If we're talking about sequestering it underground, then you'd ideally locate somewhere that has those geological formations. It costs a lot to transport gaseous solutions like CO2, so you put it there. The second consideration, which is even more important when you're thinking about them producing fuels, is renewable energy availability. So you want to ideally place in a country that has low cost and available renewable energy, especially on the grid. I think it's incredibly important when you think about producing these fuels, that it has to be the best use of the electricity. So it has to be additional, and it can't be something that would otherwise have just gone onto the grid. So countries where you've already got decarbonised grids, like the Nordics, like Scandinavia, like very sunny countries, they're the ones that make the most sense to deploy economically initially.
In terms of what you do with all that carbon dioxide that you've taken out, I know that some farming sectors use carbon dioxide. They pump it into their greenhouses to sort of up the amount of carbon dioxide in there, because the plants love it. They gobble it up, use it in photosynthesis to make tomatoes or strawberries or whatever. Would that not be another option in terms of the most useful use of carbon dioxide? Because although we tend to look at it as being a bad thing, actually, of course, it's used. Plants love it.
It's possible, and it's being done today. There are examples across Europe. I think it's a relatively small market when we compare negative emissions and transportation fuels. So for us, it hasn't been too much of a focus area, but it is important. I think I just clarify that with carbon engineering, we're focused at making climate relevant scale plants. So each of our plants is on the megaton scale. And that tends to be a lot more than a single greenhouse or a group of greenhouses can offtake in the year. So it really is looking for those bigger markets to scale up very quickly.
It's a lot of strawberries, a lot of tomatoes, and an awful lot of soda stream, isn't it? To all of that. The industry itself, the airline sector, has been trying and making efforts to make things better. I mean, looking at it from the outside, the challenge, I think, for a lot of the airlines is that the technology isn't quite there yet. And until the technology is there, their hands are tied, relatively speaking, behind their backs in terms of what they can do. How do you personally judge what the industry has done so far, and whether they are doing enough?
So I think there's been some fantastic steps. If we look at the number of airlines and the number of regions of airlines that are now committing to net zero, it's really escalated in the last couple of years, and that's the first step. Set the target. I think it's important to note that there are many airlines now that are more ambitious than CORSIA requires them to be, so then regulation requires them to be. So first step, be ambitious and set targets. Fantastic. The next step is to think about what the roadmap is to achieve those targets. And I think as I look to the example of Europe and the UK, there are very clear aviation decarbonisation roadmaps that have been produced by industry groups. Then it's the case of starting to act on those roadmaps. And what I've seen happen over the past year or so is the groups that are working on the problem have really expanded. For a decade or so, airlines have been saying, look, for existential reasons, we're going to need to decarbonise over time. But it's been a limited aviation group. I've increasingly seen fuel suppliers enter that mix, fuel majors enter that mix, the policy discussions increasing with the private sector. So I think like Jet Zero Council in the UK is a very good example of public-private partnership looking at that very question. So I think industry has done a fantastic job to bring it this far. It's now a case of having the right policy in place that rewards that decarbonisation and can bring new technologies online.
And the one thing that we talk about an awful lot, and we're going to be talking about in this year, is we have another important conference on the environment in Glasgow in the UK. It is the whole net zero by 2050. Where do you stand on that? Are you an optimist that will be achieved, or do you think it's great to have it as an aim, but we'll probably end up falling short?
Net zero has to be achieved to make sure that we don't go above the 1.5 degree scenario. It's tough. I think there's a lot of different pathways, a lot of different technologies that are being aimed at. But almost this is where direct air capture comes in, because whatever pathway you initially set out to achieve, I think there is a known solution at a known cost that can be deployed to remove residual emissions at scale and do it by 2050. So the technology exists. It's just a question, I think, of mindset shift, where instead of saying, can we afford to do this? It's more, can we afford not to? What is the cost of a world that goes above 1.5 degrees? And when you start to look at different solutions in that context, the business case just sits there to invest in.
This year, of course, has been a year where there's been an awful lot of sort of inward-looking about the state of the planet, triggered because of COVID. Do you think that it has renewed efforts within the aviation sector to look at sustainability again, or are they perhaps just been so preoccupied with struggling through this particular period that they haven't been thinking about that?
So my experience of during the COVID crisis, of having been inside an airline and then moving more towards a decarbonisation solution, is that initially there was a real scramble. The scramble was, how do we refinance? How do we restructure? What should our business models look like in this world? And the focus was very much there, and that was what was being discussed in boardrooms. And then I think once airlines almost sorted out cash burn, all of those questions, how to deal in a different world, they then shifted back to the longer term conversations. And COVID has, especially for business travel, given a new mode of working, and there is that question whether the demand will ever come back. And and if the demand is to come back, then airlines need to offer a sustainable solution for it. So I've seen it move right to the front of minds again. And I think there's been some really interesting moves over the last couple of years. Like, I call out a couple. United Airlines has invested in direct air capture. They've invested with our partners 1.5 over in the US. Delta has recently put out a statement talking about the need for geoengineered solutions in the long run. And they continue to talk about the sustainability strategy. Over in Europe, you have KLM working with Schiphol, with Sky Energy on power to liquid plants, like how can we produce e-fuels. So I maybe an initial dip, but then I've seen it escalate again. I think partly caused by consumer behaviour changing around COVID, but also COP26 has given this huge push to the world as well.
Do you think, you mentioned some of the airlines and companies within the sector which do seem to be understanding the opportunities and the challenges of decarbonisation? Do you think it's well understood well enough across the rest of the sector?
Yes. So I think, first of all, when we think about rest of the sector, I think the rest of the value chain, so the OEMs are leading to, like, I take Boeing, who are trying to test 100% sustainable aviation fuels in their engines with Rolls-Royce. I take Airbus, which increasingly talks about the need for direct air capture and decarbonisation. So OEM's very much part of that group. I think for airports, it's an important question as well. I see in the UK, Heathrow leading a lot of the debate and putting a lot of time and effort into these industry groups. I think then there's the question on the rest of the sector about the rest of the world. I would say outside in at this point, I see very much Europe leading on a number of the debates, and I think very important for airlines is to avoid international distortion. So to make sure that international agreements like CORSIA can be ambitious enough.
What you mean by distortion, I'm interpreting, is that you do something in one country which just forces all the airline travel into a neighbouring country which isn't signed up to the same treaty, that kind of thing.
Exactly. And with aviation, that might play out through fuel tankering, or it might play out through airlines moving their hubs to different countries as well. So working together on an international scale is very important. International takes time. The climate doesn't have that time. So the first step, I think, is probably a regional level, and how can Europe act in unison.
From what you were saying earlier, even if direct air capture, which is your specialty, takes off, we should still be very much focused on those sustainable aviation fuels. Am I right in interpreting what you've said as meaning that?
Yeah, they go completely hand in hand. So if I look at an aviation decarbonisation roadmap, everyone that I've seen says that the ultimate solution is sustainable aviation fuel, particularly synthetic fuels. Synthetic fuels take carbon dioxide from air, they match it with green hydrogen, and they produce these drop-in compatible fuels. So ultimately, that is the SAF that everybody would aim for. And then coupled with that, there will always be residual emissions. There is no sustainable aviation fuel that's perfect. So you do need to have that removal. So every pathway we see has complementary sustainable aviation fuel, and it has direct air capture. I think, again, the two are very complementary. When I think about what it takes to bring those synthetic fuels online, you need direct air capture. So you need it to be working at scale, and you need it to be low cost. You need green hydrogen. The problem with green hydrogen is that they have a chicken and egg situation, that whilst you can produce it, there's not enough infrastructure to take it. Like, there aren't planes set up to take hydrogen at the moment. And So they need that initial offtake market. They need people to be purchasing their products in order to be able to produce that product. Synthetic fuels give them that initial offtake market. By combining it with atmospheric CO2, you can put it in existing plane engines. So it's a complete virtuous circle between the two. One needs the other.
Because some people might look at it as having a rather awkward frenemy type of relationship between your side of things, where you're capturing the carbon, and the sustainable aviation fuels, who are saying we don't have to worry about that because we use us, and you're not, it's your net zero. But what you're saying is both are needed.
Yeah, and we play in both, right? So we're definitely not frenemies with ourselves. I think if you were looking at the cheapest decarbonisation pathway that is net zero aligned, direct air capture is the cheapest pathway available today, and will be for a long time. Like if you take sustainable aviation fuels produced by biological sources, they're going to get more and more expensive as feedstock runs out. Direct air capture will look even more cheaper in comparison, but there are co-benefits with sustainable fuels. We've been talking about carbon dioxide. Sustainable fuels also are cleaner burning. So fewer sulfur oxides, fewer nitrous oxides. Research is starting to show fewer contrails. So there are lots of reasons why you want sustainable aviation fuels. To have the optimum pathway that balances those benefits and the costs, you likely want to pair them with direct air capture. So yeah, you do both.
You mentioned a moment ago the fact that you were more hopeful that there would be bigger changes within Europe. Looking between the UK and the US, do you see big differences in terms of the approach there?
I see more similarities than differences. I think a lot of the US airlines have the same ambition as the European airlines. I think global alliances have probably really supported that view to come about. From I wouldn't say I'm the expert on this, but from having sat in the UK, I do see that the UK perhaps in particular has been pushing the agenda for quite a while. When it comes to direct air capture in particular, I'd say that it's better known in the US. Carbon Engineering is working on the first commercial scale plant over there, 1 megaton, which should be operational by late 2024. Like, that's very visible when it's on your doorstep and it's happening. Over in Europe, the understanding is maybe that the technology is more R&D, because it's not happening on the doorstep. I think there's a misunderstanding about how how quickly we can deploy it. So that's probably the difference, but yeah, similar levels of ambition across the Atlantic.
This is a very big question. I feel almost mean asking you, but if you were going to give one piece of advice to aviation, the airline sector, about decarbonisation and offset portfolios, what advice would that be?
So parking decarbonisation in particular, just focusing on the offsets, I would say that they need to be scientifically aligned. If you're just starting your journey to understand what that is, fully recommend reading the Oxford Net Zero Principles, which lay out how you should think about transitioning over time. So right now offset is extremely broad. It includes reduction, avoidance, permanence, non-permanence. But over time, the Oxford University and a number of other groups say that we need to move towards permanence and removals. And I think to explain what I mean a little bit more, and you can get an offset today that is an avoidance project. Like, you can invest in cook stoves in Africa, which are lower carbon burning. So overall, you're reducing the amount of CO2 that goes into the atmosphere, but it's still happening. You're not removing it, and you get a credit for that reduction. Over time, to get to net zero, it means that for every molecule that is taken from the geosphere to the atmosphere, you need to move from the atmosphere to the geosphere. So that means removals. And then on the permanent, on the permanent aspect, you have various different solutions that can do it. You could plant a tree, and trees are absolutely fantastic and need to be part of the portfolio, but they will last for, let's say, 100 years. They start sequestering when they're about 20 years old, and they'll last for about 100 years. You then need to replant that tree and replant it in order to avoid the carbon dioxide going back to the atmosphere. Whereas permanent removals like direct air capture, like BECCS, bioenergy carbon capture and storage, and like mineralization, capture it for 10,000 years. So you need to think about your portfolio over time, moving towards those permanent removals. So you might start today at 10% of your portfolio doing that. And then as you get towards 2050, for any offsets that you need to still do, you should be at 100%.
Amy, thank you for joining AeroTime today on Earth Day. A real food for thought there in our discussion. That brings us to the end of this AeroTime interview. Thank you for joining us. Stay tuned for AeroTime for more exclusive content from across the aviation world. My name is Martin Popplewell, and you're watching AeroTime. Goodbye.